Okay, let's see. I'm gonna turn off my video here, and then I want to talk to you guys a little bit about Linear Project Day 3. I gave all you guys the paper, right, detailing the work, right? This day is worth 18 points. This is our last day. I went ahead and came up with a couple of fake data sets here. So here are some examples that I came up with. So my first one, right, say on day 2, I was looking at the number of laps swam versus yards swam. So CBCR swim team. We practice in a 25-meter pool. So if I swim, and I guess for meters, yards, whatever, if I swim 1 yard, then I will have swam 25, uh, or one lap, excuse me, will have swum 25 yards. If I swim 2 laps, then I'll swim 50 yards, 375, and so on and so forth, right? So I've got all my data points here, and I went ahead and I marked them. And then this is perfectly linear, right? Because it's not like the number of yards is going to increase or decrease at a certain time, right? If I swim 1 lap, that'll always be the same number of yards. So, right, I can take my straight edge here, and maybe some of you did not earn full points on this assignment, and that would be because you did not have a straight edge to make your line, right? But I'm going to kind of line this up, go through as many points as I can. In this example, since I'm perfectly linear, right, I can go ahead and then draw a straight line connecting all of these points. If your data is perfectly linear, that's good, right? You'll have a nice time doing the next part of the project. So there's my trend line, right? It goes through all the points because it is perfectly linear. If you're not perfectly linear, you can go ahead and skip to my next example, where I'll talk about that. But then I kind of get to here. All right, so this next step we do 3 times. It says using the points, and I have to pick points that are on my trend line. If you're perfectly linear, your points in the trend line are the same as the points in your graph. So I'm only going to do this once for the sake of time, but you guys should do it 3 times. So say I pick the points 0, excuse me, 1, 2. This is my point number 2. And I pick the point 0, 0. This is point number 1. Right now, so I'm kind of moving from left to right. Left point was this 0, 0. Maybe I should have marked that there. And then my next point was 125. So my slope here, right, and maybe you can do this without even having to think about it, is y2. So the y value for my second point minus y1, my y value for my second point, over x2, which is 1, minus x1, which is 0. Right, so wow, my slope is 25, and I kind of could have thought about that because I knew that was how much I was changing from point to point. I want you to do this 3 times, right? Verify that no matter which points you use, you could pick any 2 points, you get the same slope if you're picking points from your line. That's the big part of this. What is my equation then? Right, I'm writing an equation like this. Y is equal to mx plus b, where m is my slope, which I just found, and b is my y-intercept. Right, so for me, my equation is y is equal to 25x plus, what am I adding to this? What's my y-intercept? 0, right? That's right across the axis. So this is actually it. This is my final equation. That's good. And so this next part, making a prediction, this is just saying whenever you plug in 15, or if you're kind of skipping around, so say you're doing years or something like that, look into the future. We're doing minutes, look into the future. Whatever your step is, do 5 steps. Me, it was easy. My step was only 1. So I'm going to plug in 15 for my x here. 25 times 15. And maybe I should have thought about this before I came up with this example, right? But I think I've got this in my mind. Let's see, that's going to be 375. This would be the number of yards that I swim if I had 15 laps. I would have swam 375. So that is what my prediction means. That's good. Is my prediction reasonable? Yeah. Yeah, for sure. My prediction is reasonable. Right? That does make sense. Like this kind of fits the expectations here, right? If I swim 1 lap, I'll go 25 yards. So then 15 laps, it'll give me 375. Yes, right? You put an exclamation point there. And so I am going to then go and show you what I want to see for maybe I'll save that. Maybe I'll save that. So now I'll look at the nonlinear example, and then I'll show you kind of the making your slide piece of this. So this next one, this is races swam versus points earned. So I don't know if you guys are familiar with swimming, how points worked, right? But here, and I actually need to go ahead and change the values in my table. And I got these next to me. So if I get first in a race, I will earn 6 points from my team. So say my first race is I get second place. I would have earned 4 points, right? That's where that's coming from. And then my second race, Say I get first place for my team. Well, there I've earned another 6 points. So 4 points for my first race, and then another six gets me to 10. Say I get first place again. Now I'm at 16. Maybe I get second again, so that's another four. And you don't really need to know how to come up with these numbers, right? This is just my made up example. Right, I'm kind of just saying, what if I finish all these? Here's a bad thing for me. My fifth race, I finished third. I got 3 points for my team. My sixth race, I finished sixth, so I get 0 points. So I add zero to my previous number there, and I get this. And again, this is all just data from maybe someone's career or something like that. So anyway, these are how I'm finishing. These are the points that I'm earning for my team, and this is my data. So I'm curious, like, can I make a model that will predict how many points I'm going to earn? And so on my axes, notice I labeled these. I've got races and points earned, and I should go ahead and graph my 0 point as well. So if I swim 0 races, I'll earn 0 points for my team. Makes sense. But then if I swam one, right, I scored 4 points. When I swam 2 races, I scored 10 points, right? That's why it's between the 12 and the 8 there. And I have all these. You can tell by looking at this, this is not perfectly linear, right? Especially I have this kind of weird flat situation going on in the middle, and this kind of curves up at the end. So this is where having a good trend line comes in handy, right? So I might have to adjust this a little bit. And I think maybe I'll like something like this, right? A good trend line for data that's not perfectly linear goes through as many points as possible and then has as many points above and below as I can. So this looks about like correct data for me. So I'll get rid of that. Yeah, it looks like a pretty good trend line. I like that. And so I'm now going to pick not points from my data set, but points that are on the line. So I'll go ahead and go with this one right here. This looks like, actually, that's not a very good example. I'll assume that this is going to go through 3, x is 3, and then y is 12. So here are my points. I'll go ahead and use 3 comma 12, right? Because that looks like it's about on my line right here. And I'm kind of just making up this point. Maybe I'll show you in red. How do I do this here? Let's see. I'll show you in red. Oh, how about that? That this is the point that I'm looking at, right? One that's on my trend line, not from my actual data. So this is point number one, 312. Now I could go ahead and pick one of these 2 points. These are on my data, right? Maybe that would be easy. If your trend line does go perfectly through your points, maybe you could use those so you don't have to kind of look for them. So maybe I'll use 1 comma 4 there. So this is point number two, right? Kind of say it's more to the right. So that's my second point. This is point number one. So my slope here then is going to be 12, my y2 minus 4, my y1 over 3, my x2 minus 1, my x1. And I get 8 over 2 or 4. All right, so my slope here is 4. And I would repeat this with 3 points, right? I want you guys to do this with 3 different points just to verify that your slope on your line is the same as you go. All right, so now I'm going to make my equation for my line, right? Again, I'm looking for a form y equals mx plus b. I know my slope. My slope, I just calculated over here, is 4. And my y-intercept, well, I've already got, that was actually one of my points, 0, 0, right? Where I crossed the axis where my independent variable was 0, my dependent variable is also 0. That's where it crosses the axis. So I'm not going to add anything to this. So now for my prediction, say I swim 15 races, how many points should I expect to be scoring for my team here? I can expect to score 60 points, right? So what my slope means, right? This was after 15 races. Oh gosh, pick up my pencil enough there. After 15 races, I score 60 points. That means my slope says that I can score 4 points per race. And so I can expect to finish second. Not bad. I can expect to finish second in all of my races there. So this is my prediction. Is my prediction reasonable? I'll say yeah. Speaking modestly, I'm pretty quick. I think that I could get second place. Yes, it's reasonable because I could get second every time. Maybe a little bit of an explanation there. Maybe I should have done that up above. Okay, so this should look like what you did before on day 2, and this is like what you're doing now on day 3. The last piece of this is your homework, is to make a slide for a PowerPoint. And I've kind of got some PowerPoint slides that maybe you can use as a template. It says on your piece of paper that you have in front of you there, part 1 presentation. You guys should make a slide. You should have a 3-minute maximum presentation on your slide, but it should look something like this, right? So here I've got my title, Lap Swam versus Yard Swam by Mr. Eversman. I'm going to do one for both of my graphs here. This other one, right, I'm going to change this to races swam versus points earned, right? That's my other topic. Okay, and I got my equation for my yard swam, right? That was 25. Oh, but I should put in my y here. Y is equal to 25x. What is my y? Yard swam. What is my x? Laps swam, right? That's what I'm changing. That was the dependent variable. When x is 15, y is 375. I showed how I calculated that. My slope means that for every lap I swim 25 yards. Great, that's what my slope mean. I know the data is perfectly linear because because twice, because the number of yards in a lap does not change. That's kind of perfect. The linear model is accurate and perfect, right? It is accurate and perfect. It will never change. It will always correctly predict the number of yards I swam. Swam. Great. Right. So then whenever I'm presenting this, I might say I picked this because I'm the swim coach and I like swimming. Why did I leave this big space here? Because I want you guys to make a graph and show us your trend line. How do I want you to do that? I want you to go to Desmos, right? So if you type in on Google, Desmos graphing calculator, it should give you a link to here, right? And here you can go ahead and graph some of your points. So I'll do my lap swimming data first. So I've got 0, 0. And then I've got 1, 25. And notice I can't see that point anymore. Here's how you manipulate your graph. Right, as I go to this little wrench thing in the right corner, top right corner, and it says, what is the range of your x-axis? Right here, the smallest value is -10, and the biggest value is +10. I'm going to go ahead and change some things up. I want to see a little bit of the negative side just so I can read my y-axis, right? I like being able to read this. I always give myself a little bit of a negative number here. And then my x-axis, I kind of go a little bit past it. I'm going to go to 12, right? My largest x value on my table was 10. I'm just going to go to 12. I just want to see a little bit more of my window than I have. I would suggest if you're going from 1 to 10, you do the same kind of thing here. My y-axis, I have a similar kind of methodology. Right, my largest x value on my table was 250. So I might say, what's 10 over that? 260. Right, here I can see 250 labeled at the top of the graph. And then my minimum, I might make this -10, right? Go 10 up, 10 below, just like how here I went 10 up and 10 below, or to be 2 up, 2 below. There, right, I can see my other point. And I could go ahead and keep graphing these, right? So I got my 2, 50. Great, that looks awesome. 3, 75. And I could go on and I could do all the rest of these for you, right? But I think you guys kind of get the general idea here. So I might, well, if I could move this. Let's see here. I'm gonna go to the other tab that I have open, which is where I have put in all of the data here. Right, here's all my data. And I'm gonna go ahead and write down, now this is my trend line, y is equal to 25x. Great, right, great. This is exactly what I want to see. And so now I'm gonna go ahead and I'm gonna go to this, my search little bar at the bottom, and I'm gonna type in snipping tool. And it's gonna allow me to take a screenshot of exactly the area that I want. So new, and I'm gonna go ahead and grab my graph here. And I should move my little zoom person first. So I'll move that. I don't know if you guys are able to see that on your end, but go ahead and do this. So snip. And I want to make sure I've got all my points in my graph and I've got my trend line. Okay, yeah, this looks great. I can see my axes. All right, they're labeled here. I can see all my dots and my trend line. It's perfectly linear data, so it goes right through the middle. So I'm going to go Control C. It's going to grab this picture. I'll go back to my graph and bam, there we go. There is my graph for my data. This is awesome, right? And I've already got everything filled in here. And I don't need to follow the advice. I feel pretty good about what we're looking at. Oh no, there we go. That's what I want to see. Sweet. And then maybe if I were doing the other one, right, this is for the not perfectly linear data, right? My equation, what we said was y is equal to 4x. I found that by calculating the slope and identifying the intercept. My y, what's my dependent variable? That's the number of points that I'm earning, right? What does that depend on? My independent variable, which is races swam. So the number of points that I'm earning is dependent on the number of races swam. When I plug in 15 for x, I find out that I earn 60 points. My slope means that for every one race I swim, I should, notice I'm using should here, should earn 4 points. Great. I know that the data is not perfectly linear because the number of points earned can change race to race, right? Maybe I get first, maybe I get second, maybe I get last. Who knows? Right, so this is not a very good predictor. Right, so my linear model, though, it is realistic, right? Because it is realistic because, right, basically, I know that I can place pretty well and earn some points. And then the model says I am most likely to earn 4 points. So this is like what a nonlinear project would look like, right? And again, I'd go back to my Desmos and I'd try to graph all these. And let's see, I'm going to try to close this window. And here I've got my non-perfectly linear data, right? And again, we found our equation before. We said it was y is equal to 4x, right? And so I kind of just typed that in down here. Yep, that looks about like the line that I had before. And again, I'll go and I'll snip this. Notice I already changed my axes. I don't know why this is not letting me snip another one. Looks like I'll just have to open it again. Uh-oh, looks like you get to see this another time. I mean to waste your time like that. Let me get this out of here. Hmm. Okay, well, either way, you get the idea. Oh, I mean that I would kind of snip my graph and I would place it in my slide here, and then I would be pretty much finished. So every group should send me their slide via email, and then everyone is going to present this. No more than 3 minutes presenting your slide. You're going to present this either next week or the week after that. And then every person in the group, so not just the people who send me their slides, but every person in the group is going to send me a reflection. What questions are you reflecting on? Those questions are in part 2 of that paper that I gave you. And so this will be due at the end of next week. Let me know if you have any questions, and good luck with this.